Well, hello all. Hope everybody's doing well. Myself, I'm doing much better than I have over the past month. I've been a little bit down under the weather, but things are getting better and we're back out in the shop once again. I just want to go through kind of a what's going on, where we're going, where we've been type of video, and we might even look at doing a little troubleshooting in this video. I think you all remember the HP 8656, and I think this was the A that we worked on a little while ago, troubleshooting, finding the problems. I finally got regulators that worked. I have ordered several different regulators from different people on eBay and so forth that did not work. The good thing was they took them back. They were local here in the U.S. But they took them back and they sent me more, and the second batch of one of the guys didn't work. Sent those back, refunded my money, and I finally got some that actually worked. So we got all the voltage rails working in this piece of equipment. Now remember the crowbar circuit on the 15 volt rail was bad, and the 5 volt rail was completely out. We had took the rails loose, injected voltage, and was able to get the unit to work. Well, after doing all that, come to find out that something on downstream further is causing the 5 volt rail to go out. So that's what I'm doing now, is trying to troubleshoot, find out which board, which area in this machine is causing the 5 volt issue. And the good thing is, I think whatever it is finally just about shorted the ground. But now when you turn the unit on, the front panel is unresponsive. So it should be a lot easier to track down where that problem is, what's causing that draw on, it's drawing a 1/2 amp on the 5 volt rail. So we should be able to find just what's going on that. And yes, beside me is the B&K 2040. This is my unit that works. It does need an overhaul, and I was planning on doing that before it completely went out on me. But we'll get back to that in just a moment. So back here in the, which was the storage room at one time, that we have finally cleaned out and got back to our original workbench that used to be in the shop. You see there's several pieces of equipment here that I'm working on. That's a Drake TR7 that I'm trying to get straightened out. It's got multiple issues with it, but I think we could fix it out. And then we all remember the SPE SP36s. And what I'm having to do, we got 3 of these in here. We're cannibalizing parts out of one to try to fix the other one so we can get one working. And the 2 schematics I have, and this is the funny part, does not match either one of these radios. So, you know, yeah, some of the areas are almost the same, but there's a lot of difference in each. All 3 radios are different. As far as the basics is still there, but you know, tracking, hunting down issues, it's a little tough on these. But you know, we're still digging on it, and this thing has been a pain, but we're closer and closer to getting it fixed now. So if everybody remembers, I've been searching for quite a while for an original FT101. This is one without any letter behind the 101, and one of my viewers on Patreon shipped this one to me and donated it to us. Now, as you can see, there's several of the knobs is missing. I have most of them. I do not have the small knob or a extra VFO knob. However, you know, we got that 101B parts unit, so we're able to take those parts off and put on this one and get the front of this one back looking like it's supposed to look. So if we pop the hood here and have a peek inside, the unit looks real good. I've already taken the bottom off and looked in there. Everything looked real good. Didn't see no burnt marks or anything. Now, as you can see, these are a little bit different than the regular 101. So by looking in the plain 101, you might already spot some differences that you haven't seen in the other 101s. One thing is the noise blanker board. It doesn't have one here like the B, E's and ups. The noise blanker board is actually on the low frequency board. If you notice, the relay is normally here on the other 101s. It is where the noise blanker board was at. Another thing on this radio, I don't know if I can see it from here. Let me see if I can get some light in there for you. Yep, there it is. You see the crystal sockets are completely empty. That's no problem. I have two sets, complete sets of regular crystals that we can put back in this unit. So looking down here, we see our audio board, but there's no low frequency board in this radio. So that has to be found and replaced. So why can't we use the regular low frequency boards like in the B's and up? Well, there's a difference. This is the low frequency board out of a E. As you can see, it's board number 1183C. And you got your single sideband filter, and your CW filter will go here, or if you modify it for AM, the AM filter will go here. Remember I said that this radio doesn't have the noise blanker board back here? That's because on the original, the noise blanker circuit is actually sitting over here on this board, and your crystals are moved on over to the center. And it would be a, I think it's a 1080. Yeah, so here looking at the manual, you can see PB 1080. There was a 1080A, which is modified, and they work in different serial number ranges. So what we need is the 1080 to go back in that plain 101. And you see there's the 1183 that's in all rest of the radios that I have. So we've got to search for a 1080A. And as you can see, there is one on eBay going for $89.95 by it now, and it has the CW filter on it. So I think I'm gonna go ahead and see if I can scarf that board up, so we'll have it for that 101. But you know, generally looking over the radio, it doesn't look that bad at all. It looks in pretty good shape. And like I say, I've looked over it and went through several of the circuits just looking, and didn't find nothing that was out of place. Now I do have to check the tubes out. Don't know what kind of shape they in, and I do have a relay that will fit in there. But if we turn around and look at the back, the lamp fuse is missing. We can retrieve that from the other 101B. And I've got to find a source for these accessory optical sockets. I need about 3 or 4 of them. Their price of them on eBay is just outrageous. I mean, they're really crazy. Now you can go on the inside, and there's 2 pins that need to be shorted together. You could do that, but if you ever want to do some testing, you might need to pull the plug out or take that loose, or if you add some accessories to it, you need to be able to, you know, pull the plug out and add what you need to it. And you know, the Flame 101, when it came out, it was discovered that there were some issues with it, and that's why they later came up with a different series on the serial number, and then they came out with the B, and then the E, and so forth, and each one got a little bit better as it moved up down the line. So I'm going to just give a thank you to my Patreon member that shipped this to us, and I really appreciate it. It's a very nice looking radio, and I think we can get this one up and going. So a moment ago you saw I had my B&K 2040 sitting on the other bench, and the reason for that was had it opened up and was taking some scope readings and frequency readings out of that particular unit, because I got one here that has some problems, and about every one of these that I run into have the same issue. Now this one's been modified. Someone's come in and expanded the frequency in it, so there's been a switch added here, and some additional circuitry in the unit to add those different frequencies. But as you can see, we're completely maxed out on the RF output on both, and you see the needle's not going all the way over 1.0 in this case. So you know, that's got to be checked out, and that's usually capacitors are going bad in the main board up here, and they need to be replaced out and then do a good tuning, and that's what mine needs, because my meter also is not adjusting right, and my modulation meter has been not going over full scale like it's supposed to. So yeah, I've got to go through mine. But the problem with this one, you look here, we're sitting on channel 1, 26965, and you see they show an output, and I have the modulation turned off. I can turn it up. This one doing the same thing mine does, doesn't go full scale. But the thing is, if we look over here at the spectrum analyzer, I got the spectrum analyzer set for 26.965, and I got a span of 40 megahertz, but you can see that the output frequency is 31.365, so that ain't right. We go up here and we look at the frequency counter. We can see a frequency of 31.340, and it's not completely stable. So what's going on in here? Well, let me move the unit so you can see better. So sitting inside the unit is this big box, and then there's another box that sits inside of it, and this is your phase lock loop circuit. And unfortunately, the phase lock loop in this particular unit has quit, and it's not running in lock. It's just free running at the moment. And here's the bad thing. Not only is this one has an out of lock problem, there's two more here, and there's two more over there, and every one of them has the same problem. The PLLs are out of lock. So there's 5 units here that has unlocked PLLs, and just cause you go in and you fix this one doesn't mean that the other 4 are going to have the same issue. There's multiple problems come up in these phase lock loop circuits on these units. Now I will say they'll work for a long time, but eventually they will quit. So the two units here on the end are my spares that I was going to fix. In fact, the top one, the end one, was working and it quit. It was the one that was sitting over here on this bench. The other one still works. So I had two of them, one for one that worked and one back up, and then another one that I was going to fix and add to the other bench in there. But I never did really get to it. Did some studying on it and trying to figure out that PLL system, and I just never got back on those. These two and this one came from an old friend of mine that has recently passed away. He had the one of the oldest CB shops here in North Carolina that I knew of, and that was Tar Heel Radio. I can remember in the 70s he had the shop then when I was young. So he was been in business for a long time. Well, Frank had some complications and he passed away not long ago. I think he was 86 years old. But even being that old, he was still out in the shop tinkering around. Now, he had closed the business down a couple of years ago and was just doing some tinkering out there. And after he passed away, one of my other friends got up with me and said, "Hey, are you interested in any of the equipment?" And I said, yeah, there was two pieces I was interested in. One of them was this particular 2040 that he was working on, and I told him when we got the chance we'll go down, we'll help him with it. Well, I ended up with three of them. You can see this one. You can see the gray or the brownish end piece side panel that goes there. This one is missing that, and it's missing that top cover, and so is this one here. So he had took those apart and was going through those, and then somewhere through the cleaning out, those pieces got misplaced, thrown away, or something. So I'll have to make two of each for these two units. And the other piece that I was interested in was this piece of equipment. Now this is Lampkin Laboratories, and it's the model 107C. Now he bought this years ago because there was rumor that the FCC was going to let the 11-meter radios go to FM. So he wanted something that had FM in it, so he had purchased this piece of equipment. And it has sat for, I know, 30 years and not even been used. Because, you know, that didn't never happen. Not until export radios came out. And I think he tried it a couple of times then. But anyway, I want to restore this, and it's mostly going to be just a conversation piece. I want to get it back looking the way it's supposed to look. And I also got the original manual for this piece of equipment. Now y'all might be wondering that, well, where the Lampkin Laboratories came from. Well, if you remember way back several years ago, I did a video on another service monitor that was called the ComServe. And it was a BR1000. After they closed that company down, they opened the Lampkin company up. Both of them out of Florida, and they started building this unit, which, you know, again, they did not stay in business long. So ComServe Laboratories and Lampkin was made by the same guys. Okay, so to troubleshoot one of these things, you've got to kind of understand how a PLL or phase lock loop works. And it is exactly that. There's two phases of signals that's you're dealing with in this thing. So a basic PLL, you will have like a reference oscillator. In this case it'll be the 10.240. That's going to come out of there and go into the phase detector. Will then come out and we're going to go through a loop filter. This will be our voltage control oscillator, or VCO. And then this goes, the VCO goes right back to the phase detector. And you can see it's a loop. And to change the frequency, you still use the reference, but you go in, you can add a divider. Divide by 10, divide by 20, so forth. And every time you do that, the output will change in frequency. This is just a simplified version of it. It's a whole lot more complicated than that, but this is just a easier way to explain what a PLL is and what it does. So your PLLs are used in multiple different things, and our application is going to be for RF frequency synthesis. So again, you know, we have our unit running. We got it on channel 1, which is 26.965 megahertz, but we're putting out 31.34 megahertz, and you can see it's changing. So that's telling us our PLL circuit is running open. It's not locking in on the signal that we want it to lock in on. So I was going to do OBS to do this video with. I decided to just go ahead and go with the video camera. But you can see this is our B&K 2040 schematic, and what we're looking at is the 10240. That's a magnet on that end. Let me turn it around. The 10240 oscillator, a reference oscillator. Now you can see this one has a 10.243 oscillator also. So there's two oscillators in this thing, but one of them does specific stuff, and they will run together in the PLL circuit. So we got our 10240 comes out, it goes through this amplifier, and then you see it goes over here to IC 310 and IC 308. Now what IC 308 is the one that we're concerned about, because that's part of our PLL. This one runs that other PLL circuit, so we'll concentrate on this one. And what IC 308 is, it's a divide by 16. So when you take 10.240, you divide it by 16, that comes down to 0.64 kilohertz. Then that frequency runs into IC 309, which is a divide by 128. So you take that frequency and divide it by 128, and you come up with 5 kilohertz. Now you can see this is running on off here on the side. So as we look, we can see these are our frequency detectors, and that's that line coming from 309 and comes into here. And this is our frequency detector, and we'll end up at IC 316, pin 7, no excuse me, pin 6 is our VCO output. That will be the control voltage that will correct, send the error pulses out to correct the frequency whenever you turn the channel selector. Okay, so again, you'll see our tuning voltage come out of IC316 pin 6, and it'll come right on around. There's a very active diode, and it goes into our VCO oscillator. Once it comes out of the VCO buffer, that'll be 26.965 megahertz, and it'll travel right on down you can see that comes right on back around, comes up to our VCO buffer and right into our mixer, and then that's when it's mixed, and you can see the loop will start all over again. So that's just a basic of what's going on here. Now I'll skip over a lot of stuff because I could spend a couple of days just talking about this. You can see here there's 3 ICs here, which is the programmable divider, and these 6 wires or 6 points here is what is controlled by the channel selector to divide the frequency to get the channel that you want. So if you remember the first thing I told you, after we come out of our 10.240 and it goes to IC308, which is a divide by 16. And what we want to do is check and see if that 10.240 is getting there. So there's a little piece of coax here that comes from that, and that goes to pin 14 of IC308. And if we look there, we see we have our 10.240 oscillating. Now it's showing 10.239.6.5. That is completely fine. So coming out of IC308, pin 11 is where we should have our divided by 16 frequency. Okay, I'm connected to IC9 pin 13, and again, if we come up here to our schematic, here is IC9 pin 13. We went in IC8 pin 14, we came out pin 11, that's at 0.064. We go into pin 1 of IC309, come out on pin 13 or 3 at 5 kilohertz. And looking at a counter, we see 5 kilohertz. So again, that 5 kilohertz is going to this frequency detector, which is IC314, and then into our phase detector. IC314 is just a 74C 74C MOS chip. I think it's a dual flip-flop. Then you see we go into IC315, which is our phase detector, and 315 is a 74C 100 series CMOS chip, and from there it comes through the low pass filter. Once it comes out of the low pass filter, this is going to be the VCO tuning voltage, and you see it's going to come down and go right into the VCO. But what we need to know, IC316, is it actually a tuning voltage there? Does this voltage change every time we change this channel selector? So let's look at let's look at IC316 pin 6 and see if we get the tuning voltage. Okay, so IC316 is this metal can transistor. It's an 8-pin transistor, and I'll zoom right in on it. And on this side is pin 1, 2, 3, 4. The other side will be 5, 6, 7, 8. So we want to check pin 6 and see what kind of voltage we got on pin 6. So we'll look at our voltmeter. Make sure I'm on DC volts. I'll sneak around here and check the voltage on pin 6. and you can see that voltage is that VCC. That's 14.4 volts, and I've turned the channel selector and nothing has changed. Now this voltage should be down to about 2 volts and should go about from 2 volts to about 4.5 volts. Okay, so if I go to pin 7 of IC316, that's the supply voltage. And you can see it's 14.37. So the supply voltage is the same as the output voltage. So that tells me right there that this IC is bad. So in this unit they're using a C3130S op amp, and that's what this is. I have some 3130E op amps, which is going to be in a dual line package like the rest of the ICs in here. Now if you look around in here, you can see IC 306 and 307 has already been replaced, and also IC 317 back here has been replaced. And the reason we know that, because those 3 chips are in sockets. And I would probably say the reason that was done was because of these channel expansion that was added. They probably boogered up the board and had to pull the 2 ICs out to fix it. Just about every time I've seen this done, the bottom of the boards are messed up. It's just, you got to be real careful when you're soldering on these circuit boards. You'll pull traces out quickly. You almost got to treat it like you're doing micro soldering on, you know, different things. You got to use low heat, lots of flux to get the joints, you know, and the solder that they're using is old, it's hard, and it's hard to get off. But anyway, this IC is going to have to come out. And in fact, it's running a little bit warm. So the thing is, we don't know if that's all what's wrong with this unit. We know IC316 should not have supply voltage on pin 6, which is the output. Now what we can do is take R385 and lift one end of it up, probably the one going to the IC, and then take that and we can inject voltage from 2 to 4 volts and see if that restores operation back in the unit. So if we look right here, that's R385. So we need to find which end is going to pin 6 and lift that end up, and then we can apply voltage to this end of the resistor and feed the circuit the tuning voltage and see if, you know, what changes. Now if you're going to desolder this from the other side, you've got to take all these cables loose on this side. It's also, there's a capacitor grounding to the chassis back here, so you can lift this board up this way, and you ain't gonna take it all out because all these wires are soldered in here. So what I'm gonna try to do is see if I can heat this up enough on this side and pull that resistor through the hole. So what I decided to do was take R385 and I'm going to clip the leads off as close to the body as possible and just remove the resistor right out of the board. That'll leave the 2 ends sticking up through the board. So I can take another 100 k ohm resistor and solder the one end and then inject my voltage into it. I just don't want to pull the board yet, and this is something that we can always do later when we find out if this is bad and we got to replace it. Then we can pull the board and go and replace that and replace this resistor at the same time. Okay guys, I got the resistor removed, and I've soldered another resistor in place of it, and you can see I have one end lifted. So this cable here is so stiff, I just put a small or more flexible alligator clip on, and I'm going to just clip right on to that voltage. Oh, let me show you this first before I do that. You can see the frequency is now at 27.965, which is way above where we need to be. So I'm going to clip on our voltage to that resistor, and you can see it came down to 27.098, and if we look at our spectrum analyzer, you see it's 27.165. I'm going to just come over here and I'm going to raise the voltage, and you see as we raise the voltage, the frequency moves, and that's exactly what it's supposed to do. And again, we'll go back to our voltage measurement on pin 6 just to make sure that our problem there didn't go away. I'll go to the edge of that resistor where I cut it loose from. Yep, and it's still at 14.4 volts. So IC 316 is definitely bad. So what I'm going to have to do is get this IC pulled. I'm going to have a socket, so I'm resocket, and the IC I'm going to put back in there is an S series, and it's in a dual inline package, so we can plug it right in. So don't forget, we still got the drawing coming up for the Testman Smart Digital Multimeter TN510. That'll be coming up pretty soon. I'm going to run along through this month some more. I'll leave a link in the description box below. If you haven't went in and throw your name in the hat for that, don't do it in this video. Make sure you follow that link and go back to the other video if you haven't done so already. Okay, I went ahead and removed the metal can IC. Wasn't very hard to do. I just added flux to the board, and then took my soldering iron, added some fresh solder, and then went back and took the desoldering tool and removed it all. And you can see right here, these 8 pins is where I removed it from. Now, you know, I told you that this thing has channel expansion in it. You can see here where they've come under these chips and cut traces and run these 2 wires and resistors. And whoever did this one did a halfway decent job. I do see some of the traces lifted, but it's just, you know, no connection on this side. It connects on the other side of the board, so not too bad. But you know, I was telling you that some more ICs have been replaced, and you can see that IC, and then look like 2 transistors up here has been replaced. And the way I can tell that is that whoever did it left the flux on the board. Now I went ahead and replaced R385, and as you can see, instead of it being laying down, I stood it up and then ran, it's hard to see, ran 1 lead straight down. This way, if it ever has to be troubleshot again with applying voltage to this, you can cut the resistor here and then solder it back together once you're finished, and that makes it a little bit easier. But you see I have the socket in place to accept the new chip. So I'm going to go ahead and put the chip in and solder the output wires back on. Okay guys, look like we have restored lock on the phase lock loop by replacing that one IC. Got the spectrum analyzer 10 megahertz span on 27.205. The generators on 27.205, and you can see on the frequency counter it's shifting back and forth a little bit, but it's very close. But the problem we have now is that when we turn the channel selector, if we look over here at the spectrum analyzer, I'm turning the selector and nothing's happening. It does not change frequency. So what that tells me is that there's also a problem with the program dividers in this unit. So we'll have to tackle that in another video. So just to show you how good the POL is in lock, look at the spectrum analyzer. I'm going to take a tuning stick and I'm going to tune the VCO. That's all the way up to 29 megahertz, and it falls off there and go back the other way. And that's down to 22 megahertz, and we'll run out of the span, but it'll probably go down even more. And back somewhere around 27.205. So what that tells me is that the POL is locked. It's staying on frequency. As I change the VCO voltage, you can see we can shift up and down the band with no problem. It's just that our programmable dividers are not working now. Anyway guys, that's what happens when you're working on these B&K 2040s, those PLL circuits. So they're good, it's built like a tank, but when you have problems, you got problems. It takes a while to work through them. You know, at least, like I say, we got it locked. Now we got to get it so that the channel selector will fix everything, and it's probably IC 306 or 307. One of those two was probably causing the problems, but we'll look at that in another video. Alright guys, hope you enjoyed it, hope you learned something, and if you would, click that like button down below, and we'll see you in the next video. Bye now.